Today's lesson is mainly going to talk about triangles and other polygons. So we want to start off with triangles, and you might not remember this, but the angles in a triangle always add up to 180 degrees. So that means that this is one angle, this is second, this is the third. Those should all make 180. So when you see a problem like number 1, it would make sense to add 60 and 65. So that's 125. And I don't have a letter here, so I'll just put a Y in here for right now as a placeholder, and that should equal 180. So if you subtract 25 from both sides, you're going to get 55. So then Y is 55 degrees. Now that you know what this angle is, you can go ahead and get X because these two guys make 180 degrees. So if we do 180 minus 55, we get 125 back. So X equals 125. The same thing here for number 2. So these two together make 69. So if we do 69 plus, let's call this M, you should get 180. So if we subtract 69 from both sides, we're going to get M equals 111. Okay, so for number 3, hopefully we got 143 degrees for letter M. And then 4 and 5, there's just a little extra step you have to do. So you should really find C first because you have the other two angles you need. So I got C as 83, but then you have to realize that C and B are supplementary, so they should make 180. And if that's 83, then that's 97. And then once you do that, now you have two angles in your other triangle, you can get the third. And it was the same thing for number 5, so those are your 3 answers. So then we're going to shift gears and talk about polygons. A polygon basically is a closed figure that has all straight sides. So really quick, we're just going to go through and make sure we understand what polygons are and are not. So that one is a yes, clearly. It's enclosed and it's all straight sides. This is still a yes, right? There's no like openings on the sides or anything. So this would be closed and all the sides are straight. And then this one would be a no. You can see this is not a closed figure. It continues down here, so it's not a whole closed figure. It kind of breaks apart. Circles, if you see a circle, that's definitely a no. They have to have straight sides. Just stuff like that. If you see a star, so you get a star colored in like this. All right, that is a yes. Because it is closed. There's no openings and all the sides are straight. So when you name a polygon, it's really easy. You pick any letter you want. Doesn't matter. So I'm going to pick letter G. And then you just go around the polygon and you name the rest of the letters, and you can go any order you want. You can go clockwise, you can go counterclockwise. So I'll just go clockwise for now. So G, B, D, H, K, M. It's kind of like naming a plane. You just go around, but you need to use all the letters. That's really important. The vertices are basically going to be the same thing, but you need a comma. So point G is a vertice, B is a vertice, D, H, K, K, and M. All right, so just make sure you have commas because you're naming each point. So vertices are the little corners. The reason you have to have all the letters is the number of letters is how many sides the polygon has. So in this case, I see 6 letters. It's 6-sided. So now we're going to name all the sides. So the first side would be segment BG. All right, and you're just going to go around and name them all. So then you'd have segment GM, segment MK, and so on until you get to the last segment, which would be DB. There's 2 types of polygons, and I'm sure you guys have heard these before, but we call them convex versus concave. The best way to describe convex to you guys is you can't connect any vertices and travel outside the shape. For example, in this picture right here, if I try to connect vertices, so let's say I connect this to this, I'm going to overlap my shape, so I can't travel like around it anywhere. That's opposite for concave. If I try to connect vertices, I can connect these two, and my line went outside of the figure, so it did not overlap. So that's what concave means. So if you look at the examples right down here, so obviously this is enclosed. You can't connect any vertices and go outside, so that is convex. Same thing here, this is also convex. However, this one, I could connect these two vertices, and I went outside, so that's a concave. Same thing here, outside, so concave. This is also convex, right? Can't do any connections and go outside. This is obviously concave. I could connect vertices here to here. And then we have convex again. So just, if you're not sure, give it a try. See if you can go outside the shape, but there's no way to do it. And then hopefully this is review. You guys can pause the video. These are the names of our shapes, all the way from 3 sides. So 3 sides is the smallest. That's a triangle, obviously. And then you're responsible for knowing names up until 12 sides. So you have to know dodecagon. That's the highest one you have to know. Make sure you look at 7 sides. It's called a heptagon. A lot of kids don't realize that. 11 sides is called an undecagon. Un means 1, and deca means 10. So together that makes 11. And if you get a polygon that's over 12 sides, we just call it like a 13-gon, a 20-gon, a 52-gon, etc. All right, so the hardest part of this chapter is all these theorems that you have to remember. So the first rule talks about exterior angles, and there's kind of an example right here. All these little angles are called exterior because they're outside of the shape. Those angles will always make 360. No matter how many angles there are, they'll always make 360 degrees. Interior angles, so those are obviously the angles inside the shape. Right? The rule with those is, doesn't matter what kind of shape you got, the interior angles are always going to add up to this formula right here. So you take the number of sides minus 2, and then multiply by 180, and that's what they add up to. So in this case, we have a hexagon, so there's 6 sides. If you do 6 minus 2 times 180, you get 720. So all these angles, A, B, C, D, E, and F, add up to 720. You will also be asked to find just one exterior angle, so you know that all of these add up to 360. But if I want to know what just this angle is right here, you're going to have to do 360 divided by the number of sides. So in this case, we have 5 sides, so we're going to do 360 divided by 5. So each of these angles is 72. And then the last rule is if you're finding one interior angle, it's basically the same thing, but you subtract that from 180. So that's one way to do it. You could also use this formula. You could get the interior sum and then divide by the number of sides. Either one works. So that's something that we will definitely be practicing next week. Really quick, I just want to remind you guys that notice we use the word regular in these rules. You can only use these tricks for regular polygons, and a regular polygon is when all the angles and the sides are the same. So if they're not regular, then these rules won't help you. So we're just going to do a couple examples here. All right, it says, assume you have a regular quadrilateral. So that means that you have a 4-sided figure. All the angles are the same. And they're going to be 90, so I'm going to draw boxes ahead of time. And all the sides are the same. So actually, it would be a square. It says, what's the sum of the interior angles? And that's the n minus 2 times 180 rule. So in this case, we're doing 4 sides. So 4 minus 2 times 180 is going to get you 360. And that says, what's the sum of all the exterior angles? And that is always 360, so no work needed for that. That's just memorization. Then it says, what's the measure of one interior angle? So what we're going to do is we're going to do 180 minus 360 divided by 4 sides. And that's going to come out to 90 degrees. And that says, what's the measure of one exterior angle? So you take the sum of exteriors and divide it by the number of sides. So we still get 90. So in this case, the interior and exterior angles come out to be the same number. That doesn't always happen. The last 2 examples, we're just going to practice using that angle sum rule. So it looks like I have 1, 2, 3, 4, 5. And these are interior angles, which means interior formula. So that would be the sum of all the angles. So obviously that will get you the answer as if you added up all these angles. 120, 95, 96, and 120. So really quick, it has 5 sides. So it's going to be 5 minus 3 times 180. And then you just simplify this side. So you can go ahead and pause the video, work it out, and then when you unpause, I'll have the answer ready. So since this object has 5 sides, we're going to put 5 in for m. And then you guys can go ahead and condense this side. So go ahead and try to solve the equation for x, and when you unpause the video, I'll have the answer ready. So hopefully you worked that out and you were able to get the answer 109. All right, so in letter B, before you do any of this fancy sum stuff, you really should look at these angles that are side by side and see if you can just use the 180 rule to figure them out. Like right here, this is 53 and something else. So just do 180 minus 53. And you can fill in that angle. So the more of that you can do, the less hard the problem is. So 180 minus 53 is going to get you 127, I believe. So that's one angle taken care of. I'm going to look around. I can't use the 180 rule here. I don't know Z. I could use it here because I know one side is 80. The other side is Y. So I could use 180 rule there. And I'm going to get 100. So that's 100. And I could also use it right here. So if I really quickly do 180 minus 62, I'm going to get 118. And that's about most of it that I could do. I could also get x because I know the other side is 95. I could do that a while. Right? That kind of makes our lives a little bit easier. So 180 minus 95 is going to get us 185. So now it looks like the only angle you have to find is Z. So if I look, I know 1, 2, 3, 4. I know 4 out of 5 interiors, and that's perfect. So we're going to use the n minus 2 times 180. Again, there's 5 angles, so we're going to do this. And that should equal all the insides added together. So Z's on the inside, 100, 118, 95, and 127. So go ahead and pause the video and see if you can work that one out. Alright, so when you combine like terms, you should have got 440 and subtract that from both sides, and we get Z equals 100. So now you got X, Y, and Z, so we're done.